So the last thing we're going to see in this section is the idea of work, where we're talking about work in the physical sense, not in the Rihanna sense or the homework sense for that matter. What we're looking at here is just force times distance. So for example, if I have my 5-pound weight here and I lift it straight up about a foot, I'm eyeballing that, or down, however long that was, I could get the work that I performed there in terms of the force, the weight of the weight, which is 5 pounds, times the distance it moved, 1 foot, to say that the work was 5 foot-pounds. And in terms of vectors, we can represent this with a dot product, where we have our force vector F and the distance vector AB. But a lot of times we're not looking at moving a weight in a straight line or pulling it in terms of something straight along a flat plane. Usually we have some amount of angle that we're moving things around. Like if we're going to drag a wagon by a handle, we're not pulling directly across, we're pulling at an angle, and as a result, it doesn't quite make sense to talk about this in terms of a dot product that way. It's actually more useful to look at in terms of the alternate formula, where we would have the magnitude of our force, that'd be the weight, times the magnitude of our distance, that is the distance, multiplied by cosine of the angle between them. Because sometimes we can just describe that angle, as we may need to be a little creative and clever about finding that angle, but that's a different story. Anyway, we'll finish this section with an example. So let's say a child pulls a wagon along a level ground by exerting a force of 20 pounds on a handle that makes an angle of 30 degrees with the horizontal, and we want to find how much work is done by pulling the wagon 150 feet. Well, we have here the magnitude of our force. We have to know if that's what we're being told. The magnitude of our force vector here is that value 20 pounds. We're also told the magnitude of our distance vector here. That is 150 feet. And finally, we're told the angle that we're working, is 30 degrees. So if we want to find the value of that small child's work, that will be the force magnitude, 20 pounds, I don't know why I was going to say 120, that'd be quite a muscular child, multiplied by 150 feet, then cosine of 30 degrees, where 30 degrees is one of those nice known values. It's just not a pretty one. It's going to end up being root 3 over 2, and 20 times 150 will get you to about 3,000. So we're going to end up with approximately 2,598 foot-pounds of work. And that's one of the main measurements of work. In this class we'll see foot-pounds. If you go further, you might see Newton meters in physics, and there are other ones you'll get from there, but this is what we're seeing here. Anyway, that's all we have for Chapter 6. So let's get finished preparing for our exam this week and start thinking ahead for our last unit. We're going to start in Chapter 9 with material I'm not that crazy about, but it's got some value. We're going to be looking at what are called conic sections, but we'll see that later.